Okay, right. So we'll start the session. So today, last week, I think we stopped at that momentum discussion part. But for the momentum and the turning effect calculations and the related theory part, I will be having another separate live session and will be discussed in another separate session. Okay. So for today, I will be trying to finish all the theory related to electricity, which is unit 2. So this thing will be discussed. This thing will be discussed not in the exact order which is given in the textbook, but I will be using another special method and we'll be discussing, right? Okay, so when it comes to electricity, the unit 2, uh, there are four main topics. So unit 2, there are four main topics, which is the mains electricity. Then we have current and voltage, I and V. Then electrical resistance. And finally, the last chapter is electric charge. So, though this is the order given in the textbook, but I will be starting from electric charge, then the mains electricity, and finally about current, voltage, and resistance. And remember, most of the calculations will be based on these two sections, right? So these are the parts that you get the calculations, and the other two parts will be focusing on just the theory parts, right? So within these 2 hours, I'll try to go through all the most important theory stuff, right? So I will be starting from electric charge. So when it comes to an atom, right? So you need to have this basic concept. So we know that we have the nucleus here, which has the protons and the neutrons, and around it we have different sort of energy levels, and in these energy levels the electrons are orbiting around the nucleus. So these electrons are having negative charge, and these protons are having the positive charge, and this one is neutral. So therefore, what will happen, these negative and positive charges will be having a small attraction force, and that is the main reason for keeping this electron attached to the nucleus, right? So as in the previous cases, we mentioned that like if you need to have some sort of an electric current or something like that, then we need to have the movable electrons, right? So when it comes to electricity, so you need to know these two terms, the difference between these two terms. So when it comes to electricity, it can be either because of the stationary electrons, and it can be either because of the moving electrons, right? Moving electrons. So this stationary electrons thing, that is known as static electricity. Static means not moving, right? Stationary. Static electricity. And the electricity generated due to the moving electrons, that is known as current electricity. That is known as current electricity. Static versus current. So first of all, before starting this lesson, you need to remember, you need to know the meaning of static electricity versus the current electricity, right? And so here the electrons are the most, that is the major component of making electricity, right? So these electrons must be moving here and there, right? They must be delocalized or must be moved from to a place to another place. And there are some other terms that you need to know. When it comes to different sort of materials, or we can say matter, right? Then, so they can be either conductive or insulative, right? Conductive and insulative. insulators or something like that. Okay, insulate, right? So here, conductive means a certain property must be transporting through it, right? So that specific property can be either thermal energy, electrical energy, sound energy, like those things, right? So here in this lesson, mainly we focus on the electrical conductivity. So therefore, here a conductive or conductor, right? Conducting material means that material can transfer energy, right? Can transfer electricity here, right? Can transfer electricity through its material or matrix, right? Just a rough idea. And insulation or insulator means it cannot conduct this electricity, right? So you need to know these terms and some examples as well, right? So here for the conductive materials, you can take water, right? And metals. And in some cases, we can get dry air and high pressurized air, like those things. And insulation, you can have dry wood, right? Dry wood, plastic, wood, like those stuff, right? And here, the next important fact that you need to remember is, so there will be forces generated between charges. So in order to get a charge, right? So this is now something related to chemistry as well, right? So in order to get a charge value, so here let's say we are having the neutral material. This is the neutral material. And if, let's say, electrons were removed, so here electrons were removed. So therefore, you will be getting the positive ion here, right? You will be getting the positive ion. The reason is in normal neutral conditions, the number of positive charges in the nucleus will be equal to the number of negative charges. So, but if you change these numbers, let's imagine, so here you are changing this value. So therefore, you will be getting a higher positive value. So special, like a small thing, right? Small thing is there. You can apply the numbers and see. And here in the other way, if electrons are gained, then the minus charge value will be going up. So therefore, you will be making the negative components there, right? In most of the cases, right? There are some situations where you can change the protons and like this, but in your level, we won't be discussing about it. So remember, if there's a component to be charged in positive way or in negative way, remember always we are dealing with only with the electrons. We are only dealing with the electrons. Okay. We are only dealing with the electrons. And when it comes to forces between these charges, right? These are some simple stuff. That's why I am rushing through this thing, right? When it comes to forces, so always remember, if it is positive and negative, then there will be the attraction, right? There will be the attraction. So I'll leave it like this. Then you can clearly remember. So if it is the same charges, then it will be repelled, right? It will be repelled. So remember these points. And there were some situations like where there were several questions where how to attach a certain substance, even we discussed this in theory classes. So we are having a balloon like this, and the wall surface is negative, and this surface becomes positive, and there will be an attraction force between these two. Like there are some theory parts that you need to remember. Okay, you can refer the textbook as well. So many examples are given there, right? So then the most important part that you need to remember when it comes to this static electricity part. So here electrons are not removed actually. Removed means like they are not moving, right? There's no flow of electrons. So therefore, the small current that is generated due to these static electrons, right? Due to these static electrons, that is known as the static electricity. So you will be having a small current actually, right? We'll be having a small current. And most importantly, like most of the calculations, most of the questions are given in the uses of static electricity part. Uses of static electricity. So here, the most important one is the electrostatic spray painting, right? I'll just write the spray painting, electrostatic spray painting. So the main theory is, remember, so here we are having the spray gun. Okay, we'll draw it like this. And we are having the object here. So our main theory is that, so according to this diagram, if you are having the attraction force, then these paint molecules, these paint droplets will be like thoroughly attached to the framework or something like for the object, right? So that is the main theory that we are using here, right? So which means in order to attach these paint droplets, let's say I am spraying some sort of droplets here, right? Like this at a certain distance. So I need to make these droplets attached to this object. So which means definitely you need to have different sort of charges in the framework, in the object, as well as in the paint molecule as well, right? So it can be either positive here and negative. So just imagine you got positive and positive here, then what will happen? These paint droplets will be repelled from the frame, right? Will be repelled from the frame. So therefore, in normal cases, right? In normal conditions, actually, we are making this frame to be negative. How? We are going to attach it to a negative terminal, right? And the paint droplets will be positively charged. So that is the first main point that you need to remember, right? Two different charge values for the object and the paint droplet. And the next question they are going to focus on is that the paint will be sprayed in a wide range like this. So let's come imagine these two paint droplets, right? So if these two are having two different charge values, then what will happen? These two paint droplets will attract to each other, right? Then it will be forming a huge lump of uh, a paint molecule. So that is a disadvantage here, right? So once this is attached to the frame, what will happen? You will be getting those different sort of lumps in the frame, in the object, right? So if you need like a soft layer, like a very thin layer of paint applied on the object, then what you should do is that you need to have a evenly distributed paint spray, right? So therefore, what we'll do is that you need to make these paint droplets in the same charge value. So now what will happen? They will repel each other, making an even paint spray, right? So that is the second point that you need to remember, right? First point is why we are making the paint drops and the object that we need to apply paint in opposite charge values and in opposite charges. And the second question is that why do we need to use the same charge for the paint droplets? So you can explain it. So this is the most like widely questioned theory part in the exam. And the second one is the inkjet printer. So here in the inkjet printer, we have two different plates. And remember, these two plates, they can change the polarity. we'll say the charge, right? They can change the charge that they can get, whether it is going to be positive or negative, right? The constant thing is here we are dropping the ink from the reservoir, right? Let's imagine here we are having an opening, and this is the place where you have the ink, and this is a ink droplet, right? This is an ink droplet. So remember, definitely this ink droplet will be minus, right? It will be negatively charged. It will be negatively charged. So that is a constant value. We are not changing the charge value or the charge of the ink droplet. So it will be remained as a negatively charged object. The changing factor is that, let's imagine we are changing this to be positive in the first situation, and this is to be negative in the second situation, right? So the trajectory, the path of this ink droplet. So ink droplet is negatively charged. So here this plate, I will label this plate to be A and this is to be B. And so plate A is positively charged. So therefore what will happen? There will be an attraction. So in the meantime, so if this place, if we consider this place, then there will be an attraction towards here. So therefore, eventually the trajectory path will be changed like this. And also remember, right, if there's a question given, like this was actually a past paper question, remember, don't draw this ink droplet to be attached to the surface. That is wrong, okay? So I'll make a, yeah, that is wrong, okay? It is not going to be, it is not going to land on the surface. There's no point of landing the ink drop in the plate. So we need to drop that ink in the A4 paper, right? Where you need to get the print. So remember that point. So the path will be something like this, right? So if you consider this is the first situation, so you can change the direction of the ink droplet like this. And if just imagine, if you need to change the path here into this side, then what should we do is that we need to make the B plate to be positive, and eventually A is going to be negative. So you need to repel the ink droplet from like away from A, right? You need to repel the ink droplet away from A. So you need to make it negative, and the B plate will be positively charged, right? It will be positively charged. So remember this theory, and there was a good calculation related to this thing, and we'll use that linear motion equations as well, right? So please go through that question once again, right? And there are so many applications related to this static electricity photocopiers and electrostatic precipitation part. So please go through them. So actually, those two examples are actually not tested in the exam. So you have some sort of an experience, right? We completed like nearly 40 papers, but we came across like in between, like, you know, in the inkjet printer and this static thing, static electrostatic spray painting thing, right? So the final two, that precipitators and the photocopier machine, it's not tested yet. So please pay more attention to those two, right? And the next one is the problems related to static electricity. So problems means like how, so you need to know how the static electricity is generated, right? So remember, uh, the problem arises if the static electricity is being made, right? Static electricity, if the static electricity forms. If the static electricity forms, then there will be a problem. How it is going to be formed? How the static electricity is going to be formed? The main reason is the friction, right? The friction. So now address the problem. So the first example is that aircraft thing, right? So when the aircrafts are moving through the air. So in air, you have those dust particles and different sort of water molecules and all different sort of molecules there. So what will happen is that they will be rubbing against the surface, and eventually they will exchange electrons, and these surfaces will be having some sort of a charge value. So once, just imagine they have landed, and the surfaces are charged in different manner, right? So therefore these charges can escape. So you will learn these things in later on. Like if you are having a difference in charges, then they will try to balance it actually, right? So where you have a higher charge value, the charges will escape to a lower charged value place, right? So therefore there can be a small spark. So once there's a spark, then there's a slight possibility of having an explosion. So that is the main thing that you need to remember, right? So the first one is the airplane thing, and the other one is that the tankers, right? The oil tankers example, right? So here you might have seen some sort of a like a chain hanging. The reason is to minimize that charge difference, right? So here, I'm going to mention that thing again. So this is not a complete note. This is something like a short note in order to memorize all the stuff that we have discussed, right? Then about the mains electricity. So this is the yeah, this will be the short note for the static electric part. Then we'll start the mains current thing, because I need to pay more attention to that resistance part. Okay, so that's why I am rushing these things. So mains electricity here, you need to have an idea how the electric circuit works in your household, right? So you will be getting the power, and you are using different sort of fuses and circuit breakers likewise. So here I will give you some sort of questions. Then please go through them and revise them, right? So first of all, you need to have an idea about the electric circuit in your household, right? So I will write it like this, the electric circuit in the house. So electric circuit in a sense, like I want you to have an idea how the appliances are like wired, and like like what at which place we are using the fuses, like those stuff, right? And the next one is yeah, next one, uh the most important one is the colors, standard colors that we are using in wires, right? Colors in wires. So try to remember them. If you are using the green wire, green mixed with yellow or something like that, then that is the earth wire. That is for the earth wire. And if you are using a brown wire, then that is the live wire, right? That is the live wire. And if you are using a blue colored wire, then that is the neutral one, right? Neutral wire. So remember them, okay? Remember them. And next question, uh, the fuses, right? The fuses. Under that thing, you need to know how they work, right? How they work. Like in previous, as I can remember, in 2025 paper as well, like in November paper, they asked what is the difference between the fuse and a switch or something like that, right? So try to, like try to revise those papers as well. Please go through them and revise those questions. I'm not asking you to memorize all the questions. Just go through the question and understand what they are asking for, right? Fuses and how they work, and the conditions actually, right? The most important thing is the conditions that we need to use. Conditions in the sense like there's no point of using, let's say, there's a 5 ampere current, and they are asking what is the fuse, the most suitable fuse that we can use. So there's no point of using 13 ampere fuses or something like that, right? So the most correct one would be 6 ampere or 7 ampere. So likewise, you have different sort of fuses there, right? And so remember the conditions means like the highest value, right? So it can be either +2 or +1 amount of amperes, right? +1 or +2 amount of amperes. So normally, like try to get the value from +2, right? Normally, that is the answer. But depending on the situation, right? So there will be a range of answers, but try to use it properly. And it is also mentioned in the textbook as right? Textbook as well. And so then the next one is the yeah, the next thing is the double insulation process, right? So try to understand the term. So here you are having the insulation. So insulation means you are blocking the transfer. So in this situation, it is electricity, right? So you are going to insulate electricity, which means you are going to block the path for that certain material, right? Block the path of electricity for that certain material, but not just once, you are going to block the path twice, right? You are going to block the path twice. So here the method that we are using, the first one is, so uh, there's no actual order, but these are the two situations, these are the two methods that we're using. So first one is you can have the earth connection with the earth connection uh, with the component, right? So earth connection means like if there's a like uncontrolled electric surge or unsafe electric surge, so that then this earth wire will be directing that current towards the earth, right? And the second one is you need to use the insulating material cover, right? So that's why, like in those ages, your parents might have remember like in those ages we had those irons where the cover is also made out of steel, right? And even some electric kettles as well, right? In yeah, even now we can find those electric kettles as well, made out of using steel or some conducting material actually, right? But nowadays most of them irons and even electric kettles you can see they are made out of plastic. So plastic is used as a insulating material. So here it can be plastic like those materials, right? Okay, so then so those are the points that you need to remember here. So remember, and colors in wires, and also remember this part, I forgot to mention it. So if you are going to use any sort of switch, right? Any switch, any sort of a gate actually. So gate and a switch are same thing, right? Acting as the same thing. So if you are going to use a switch, then it must be definitely in the live wire, right? It must be definitely in a live wire. Remember that point, because as I can remember, there were several questions, I think, in the I think in all syllabus. So somewhere else, I can't remember the actual paper, but it is actually mentioned in your textbooks as well, right? Which means they can ask questions from them, right? So remember, there's no point of having a switch on the neutral wire. It must be definitely on the live wire, because live wire means always you are having some sort of a electricity, some sort of an electricity current flowing through the live wire, right? Always you are having it. So, and here, purpose, right? Try to find the purpose of these wires, right? Why do we need the earth wire, and why do we need the neutral wire? Likewise, try to find the purpose as well, right? Like no need of writing, and just if you can remember, then it is okay, right? If you can't remember something like that, then please write and try to memorize those things, right? These are simple theory parts, like you will be getting 2 or 3 marks for these writing sessions, right? So try to do something like that. Okay, then the heating effect and the electric power. So there are equations. No point of remembering equations. You will be given that equation booklet. But what do you call? My recommendation or my advice is that don't just depend on the equation booklet, right? So if they are asking any sort of equation, then definitely it won't be given in the booklet. That is the situation, right? So it's better if you can remember all the equations. uh, Once after this session is done, I will upload all the that I think I have given you that equation, the equation sheet where you have all the equations, like nearly 15 or 20, I can't remember. So I will upload once it again. So I will upload it again. So then if you need, you can take a printout and try to memorize the equations, right? So that is the best option. Don't just depend on the equation booklet that they will be giving all the equations, right? So remember, if they are giving any sort of a question related to if they are giving any sort of question related to uh, asking equations, then definitely they won't be included in the equation booklet, right? Then yeah, we'll discuss. Okay, for the equations. Right, right, right. I'll discuss it. So go through the heating effect of current as well, right? Heating effect of current. And under this, so here the heating effect of current, there can be disadvantages as well as advantages. Okay. So the advantage of heating effect is that, just imagine you need to make some sort of a let's say heat energy, thermal energy, then we can use that effect. But if it is in the disadvantage side, let's say you are using that yellow color tungsten bulb instead of a CFL bulb. So in that bulb, what will happen is that, like even we discuss these things under the energy related physics question papers as well. So in the tungsten bulb, what will happen is that tungsten bulb, 80% will be heat energy and just 20% will be the light energy, right? So we are using a bulb in order to get the light energy. But what has happened is that majority of the energy will be wasted upon heat. And advantageous part, just imagine you are using an iron. So if you need to heat something, then definitely you need to focus on the heating process of this uh, metal, or the heating process, heating effect of the current, right? And here there's an special equation that you need to remember, is that the power equals voltage into current. So the equation is P equals VI. P equals VI. Remember it. just remember one or two equations, then you can derive the other equations, right? So we'll discuss about the equations later on. So in this sort of equation, definitely two terms will be given, and the third term is to be calculated, right? And so this is the first equation that you need to remember. And the second equation is that, so here we can convert this power into what you call uh, something related to energy, right? So that equation is energy equals VIT. Energy equals VIT. So how we got this equation is that, so power will be equal to energy over T, right? Energy over time. I don't think I want to write it. So just remember it, okay? So power equals energy over time. Then you can apply this equation and get the third equation, second equation, right? These are the equations that you need to remember. So I'm not going into those simple calculations, and remember time will be definitely applied in seconds. Those are some simple stuff that you need to remember, okay? Those are some simple stuff that you need to remember. Right. And the unit that we are using to measure power is going to be watt, and energy, joules. So please remember them. And the most important fact under this mains electricity is the alternating current and the direct current, right? So here I'll write AC versus DC, right? So still now there's a, like, there's a fight between which current is good. Like the alternating current is like some people say alternating current is better than direct current, and the other ones having the opposite ideology, right? But here there's a clear difference between AC and DC. And so the simplest idea is that uh, AC means the current will be flowing in two different directions, right? So for the first second, let's say in the counterclockwise direction, and in the very next second it will be having a different direction. But DC current will be having just a one direction, right? So that is the most simplest way that I can explain it, right? So for the AC current symbol, remember, you will be using a wave like source like this. So this is the circuit symbol for AC current supply. And for DC, you can just use any sort of a battery symbol or something like that. Okay. This is going to be positive end. This is going to be the negative end. So that will be the symbol for the DC current. And if we consider about the graph structures, right? If we consider about the graphs, so this is somewhat special here. So if this is going to be the graph, so let's say here we are dealing with the voltage, and here it is going to be the time, right? So for the okay, let's say like this, right? For the DC current, it will be just a one direction, right? So this is going to be the DC. And if it is the alternating current, so alternating current, like within a given second, the direction changes, right? So if we take this is to be the first second, likewise, you have the time intervals. So in the first split second, let's say this is the positive direction and this is the negative direction. So in the first split second, you will be having a positive direction current. And in the next one, you will be having a negative direction, positive direction and a negative direction. Likewise, the current or the voltage changes, right? It will be continued like this. And so the first thing is the current or the what do you call that, the voltage will be changed. And there's a major thing that you need to focus on. So here in alternating current, right? Alternating current or alternating voltage, you can see that. So if we consider about the DC current, here you can see only it is fixed on a single value, right? It's fixed on a single value, only this one, right? This is the specific fixed value. But if we consider about the AC voltage or the AC current, you can see starting from zero. So if I get values, then you can clearly understand. Let's say this is +2, and this is going to be uh, let's say this is going to be +1. This is going to be zero point 0.5. This is going to be 1.5. Likewise, right? So here you can see that the current you have 0 to 0.5, 1, 1.5, 2. Then again the change values changes. Now in the negative direction, what will happen? You will have the same negative values. Ne? So you will be having negative 0 0.5, negative 1, negative 1.5, and negative 2. Likewise, you will be having a range of values, right? So here I write, you will be getting a range of values. So in this case, it is +2 volts to -2 volts. Okay, I'll label this one as -2. So remember that point. There's a range, but when it comes to DC current, DC current or DC voltage, you will be having just a fixed value, right? Just one fixed value. And also another thing, so this sort of a wave structure, this is known as a sine wave, right? You will learn these things in A-level maths, and there might be a chance if you follow A-level physics, you might come across these terms, right? So this sort of a wave, the reason is like there's a math explanation. So for you guys, there's no need of knowing that this sort of a wave that is known as a sine wave. And always remember this point. If you are getting some sort of a signal like this, still this sort of a graph falls under alternating graph, right? Remember these shapes. And just imagine, like, let's say this is 0 and this is going to be +2 and this is -2, right? Having the equal height values. And just imagine you are getting a digital signal, something like this, having different sort of height values. Having different sort of height values. Having different sort of height values, still falling under alternating current, right? Still falling under alternating current. So there are different names given for these type of graphs. No need of knowing. The fact that I need to emphasize was like for this DC, sorry, for the alternating current, uh, don't just get fixed on the sine wave shape, this wave-like shape, right? You can either have those these pillar-like uh, shapes as well, right? So remember all these two shapes also falling under AC current or AC voltage shapes. Okay, right. Then we'll start current voltage and this resistance thing, right? So this is the most important part in electricity. The reason is like most of the calculations are based on current, electricity, current, voltage, and all the stuff, right? So here I will be like, going through it, rushing through it, the circuit symbols and all the stuff. So by now you know the circuit symbols and all the stuff, right? So I'm not going to waste more time on it. Uh, I need to focus more on the resistance calculations, right? So here, uh, so uh, let's say current. So current will be equal to number of charges divided by the time that we took. So the equation will be I equals Q T, right? I equals QT will be the equation. So if we consider about the units here, remember charge that is measured in coulomb, right? That is measured in coulomb, not in amperes, right? Charge is measured in coulombs, right? Coulombs. Symbol is capital C. And time measured in seconds. So therefore, current coulombs per second, or most of the time we will be using amperes, right? But remember, current, the initial unit, right? The main, not the main unit. Ampere is the most like widely used unit. So coulombs per second is the correct unit. Okay. So coulombs per second is the correct unit. Then when it comes to current, we need to know how to measure it, right? So I'll just prepare this thing, how to measure. So how to measure? We are using amperes. This is the, sorry, ammeters, right? Ammeters or milliammeters, right? And next thing, when it comes to an ammeter, you need to know how to connect it, how to connect it to a circuit, right? So this is going to be in series configuration, going to be in series configuration, which means just imagine in this circuit, right? So I'll use a resistor like this, right? So you need to measure the current which is flowing through this circuit. So then you are going to connect it in series with the appliance, right? With the appliance. In series means in the path of current, right? This is the way where the current flows, right? I'm just rushing through these things, right? I'm going to do some sort of a revision thing. That's why, right? So this is the series configuration, right? Then the voltage, you need to know what is meant by voltage, right? What is meant by voltage? So simply we can say voltage is the energy given to the circuit by the source or something like that, right? Energy given to the circuit by the source. And next you need to know how to measure it. How to measure the voltage. So in order to measure the voltage, we are using voltmeters, right? And this voltmeter is going to be parallel to the appliance, right? It is going to be parallel to the appliance. So in the previous case, ammeter was in series configuration. Now the voltmeter is going to be in parallel configuration. So which means, just imagine something like this. This is the resistor, and we'll say here we have the bulb, and this is the circuit system, right? Circuit is a completed system. So if they ask you to you need to measure the voltage across resistor, then you are going to connect the voltmeter like this. If it is voltage across the bulb, then you are going to connect it like this. If it is the voltage, if it is the voltage across the power supply, then it is going to be like this, right? So always in the parallel way, right? In the parallel manner, in the parallel manner, right? Then, okay. So there are some calculations given in your textbook as well. So please go through them. I'm not going to go into deep theory discussions here. And also remember, you need to remember the circuit symbols. Circuit symbols won't be given in your exam, right? Circuit symbols won't be given in the exam. So you need to remember them. And the most important part here is the series and the parallel circuit configurations. So we will discuss about it before going into the next one. Right. So here, so circuits. So if I ask what is a circuit, what is an electrical circuit, then you can say it is a graphical representation of a experimental circuit, right? Or a setup, right? So in this case, we are not going to draw all the actual component the way it is, but instead of that, we are using the circuit symbols, right? So right, so those are some simple stuff. So when it comes to circuits, it can be divided into two major groups. You are having series circuits and parallel circuits. Series circuits and parallel circuits. So in series circuits, the simple definition is that there's you don't have any sort of junctions or branches, right? There's no junctions or branches. And in parallel circuits, you do have junctions, and therefore you will be getting branches, right? Junctions and branches. Junctions and branches. So if I draw a circuit something like this, so I'm going to use a resistor and a bulb as well, right? So one resistor, I'm going to use a resistor and a bulb. So in series configuration, like this. And here, so this is the positive end, this is the negative end. So once you get, so this is the most important step in your calculation related to electricity, right? So once you get any sort of a circuit, so first of all, take a pencil and go through the line, right? So here in this case, so let's say this is a circuit that you got. So first of all, label the positive end and the negative end of the battery. Then, so positive from the positive end, you will be experiencing the current. So this is the current direction. So go through the circuit line like this, going through the resistor, going through the bulb, and returning to the source. So in this path, you can see there are no junctions, right? These places are considered to be bends, right? It's just a bend. There's no junction. It's not divided like this, right? So therefore, this can be considered as a single path actually, just a single way, right? So no junctions, no branches. So therefore, this is considered to be the series circuit. So the same circuit can be drawn in a different way. So here, I'm going to divide this little branch here and resistor like this. And the bulb, I'm going to attach it like this. Now you can see, right? So this is the positive end, this is the negative end. So the current will be started from here. It's a bend, right? First bend, then now you can see there are two clear passages like this, right? It is now bend, like divided here. You can either go from here or you can go from there, right? So therefore what will happen? This is a junction. So the current will be divided actually, right? The current will be divided like this. So this is considered to be a parallel circuit, right? This is considered to be a parallel circuit. So there's an important fact that you need to remember, right? So just imagine I am using a, let's say, a switch here. Let's say here, right? I'm using a switch. So if I switch off this gate here, right? What will happen is that I will cut off the path to, uh, I will cut off the current path to this resistor and the bulb at the same time, which means I can switch off these resistor, that appliance, or the bulb within a single click, right? And here, just imagine I am using a switch here. I'll say switch A and switch B here, right? Switch A and switch B. And let's say something like this. I'm using another switch here. This is switch C. So if I switch off, let's say all the switches A, B, C they are switched on, which means they are closed, right? The path is completed. So what will happen? This bulb and this resistor will be working. And if I switch off this thing, which means the switch is open now. This is closed, and this is open. Now what will happen? Either bulb or the resistor won't be working. The reason is the main path has been cut off, right? The main path is being cut off. And just imagine I am switching on this thing and switching off this one. So now the resistor won't be working, but the bulb will be working. And if I switch off this thing, right, this is not working then, right? This bulb won't be working, but still you are getting current in this path. So therefore, the resistor is working, right? So that is the main difference or the main use case scenario in the parallel circuits, right? So in your houses, like the main circuit, the main current circuit is wired in the parallel manner. That's why, like, if you switch on a bulb in a different room, the other rooms won't be affected, right? But in if you are using this sort of a thing, just imagine you are having a switch, a single switch, right? Where you can switch on, then you can switch on all the bulbs in the house, right? And if you switch it off, then you can switch off all the appliances and all the bulbs that you have in the house with a single click, right? With a single click. And just imagine, so these are actually questions that they tested in previous cases, right? So just imagine this resistor went off. Let's say it burnt actually, right? Now it's not working. So now what will happen? This path is now blocked, which means this bulb won't be also working, right? So this is actually some sort of a disadvantage here, right? If one appliance get blasted or burned, what will happen? All the other appliances will be affected. It won't be working. They won't be working. But in this case, what will happen? Just imagine this bulb blew off, right? So what will happen? Doesn't affect for the R. The reason is it is on a different path, right? So in this path, you won't be getting any current, but all the current will be flowing in this path. So therefore, this is not going to be working, but this resistor is going to be working, right? So get the idea properly, the difference between the series configuration and the parallel configuration, right? Okay. Then before moving on to the next one, I want to emphasize something else, right? So when it comes to a series configuration, uh, I'll use R1, R2. These are resistors, right? Like this. And the parallel circuit, same thing, R1. This is going to be R2, right? So we'll say this is 12 volts, same supply. And here I'll say, mm, let's say a simple value. I'll take a simple value, right? We'll say 2 ohms and 3 ohms. And here it is going to be 2 ohms and 3 ohms, right? Right. So I'm going to explain that total resistance situation as well, right? I'm going to explain it. So in resistance, no, before going into that, yeah, just give me a minute. Right. So we'll before going into that resistor thing, first of all we'll discuss about that voltage differencing. We'll discuss about the resistors, right? So here the resistance. So the general idea or the simplest idea is the barrier for current, right? So it is going to be a barrier for current, right? And the next important thing is that you need to remember is if you are having a higher resistance, right? Higher resistance, then the current will be low, right? Instead of writing this sort of a thing, I'll write a relationship, then you can clearly understand, right? So the current inversely proportional to resistance. So which means if you are having a higher resistance in any sort of a material, then the current that can pass through is going to be a low value. If the resistance is lower, then the current is higher. And there's another important thing that you need to remember. This is something extra, right? So remember this. This is even not explained in your textbooks. So if you are having a higher length or sort of things, then what will happen is that just give me a minute. Right. So if we consider about a wire, let's say something like this, right? You are having a wire. So the surface area is A and the length like this. So the resistance can be calculated. There's a equation. Equation means like there's a relationship, and by using those relationships, they have derived an equation. So equation is that R equals rho L over A. So this thing, no need of remembering. The reason is it is not mentioned in your syllabus, right? The thing I need to emphasize is that the resistance is directly proportional to the length of the material. So which means if you are having a higher lengthier wire, right? A lengthier wire, what will happen? The resistance will increase, right? The resistance will increase. So this thing is actually explained when in magnetism, right? So if you can remember, when we are using those step up transformers and step down transformers, when we need to supply the power into the national grid, in those cases I mentioned that you need to supply a huge amount of the power, that voltage there, right? So normally we are supplying in Sri Lanka, it is around 33,000 voltages, right? So and so if we consider this is to be Sri Lanka and the power generation here Colombo, and you need to just imagine you need to send the power to Kandy or somewhere like that. So here it is nearly 120 kilometers. Just let's take, right? So 120 kilometers, that power must be get going, right? So therefore, the length is higher, right? So therefore, with the distance, what will happen? The resistance will increase, right? So which means the power wastage will be a huge value. So in order to like, there are some concepts to minimize or some approaches to minimize the power wastage, but the main thing is that we are providing a huge amount, a huge power input from this end, and we are getting a less amount here. So we can't do anything about the power wastage through this path, right? So I wanted to emphasize this thing. If just imagine in a circuit, you are using like lengthier wires, right? In order to construct a circuit, you are using lengthier and lengthier wires. So what will happen? The resistance will increase, right? And also here you can see the resistance is inversely proportional to surface area. So which means not the surface area, uh, the cross-sectional area actually, right? So that is the cross-sectional area. So if the cross-sectional area is higher, what will happen? The resistance will decrease. So here, no need of remembering this, but the first point, I think it's better to remember this thing, right? So, and remember, don't write these any equations in your exams. You won't be getting getting marks, huh? So remember that. The only point that I need to emphasize was this thing, right? The resistance is directly proportional to the length of the material, right? Length of the material. And the next one is the resistor systems. So when it comes to resistor systems, here also you have what do you call that? Series and parallel systems. Series and parallel resistor systems. So series means if I draw a simple setup, so then you will be having R1 resistor like this and another R2 resistor like this in the series manner. And in parallel manner, you will be having R1 like this and R2 like this, right? So this is a parallel manner. So once you are getting a resistor system in your equation, so first of all, you need to identify whether it is a series manner resistor system or a parallel manner resistor system. So that is the first breakthrough that you need to make. Okay. Otherwise, the calculations will be wrong. Okay. So when it comes to series system, so I'll complete this diagram. Let's say like this, and this is going to be like this, right? So sorry for these bad diagrams. The reason is like my pencil, the battery battery is dead, so I had to connect it to another source, right? So now it is like attached to another source, so I can't freely move the pencil. So forgive me for that bad drawings here, right? Okay, so here once you get a diagram like this, take a pencil and do something like this, right? So first of all, mark the positive end and the negative end of the power supply. And let's say something like this. So this one will be giving a V voltage, right? It is mentioned as giving a V voltage. So the voltage means actually the difference between the positive end and the negative end, right? So try to grab this idea, right? There's a potential difference. The reason is this end is positively charged, this is negatively charged. So therefore, you are having a potential difference. There's a difference, right? So that potential difference is V, right? Which means this difference between these two plates is V. So if I take, right, now try to grab this properly. If I take this end to be positive V, then this end, it is not minus V, it is going to be zero voltage, right? Just imagine it is minus V, then the potential difference is going to be 2V, right? If you apply, let's say numbers, right? So we'll say something like this. This is the power supply. And they have mentioned this is to be 12 volts. So this is the positive end, this is the negative end. If I consider this is to be positive 12 and this is going to be 0, now I can get the difference, right? So the voltage gap is 12 minus 0 when you are getting 12 volts. If you get this value to be minus 12, what will happen is that delta V is going to be equal to 12 minus 12. That is the gap. So then you will be getting a voltage difference of 24. So this is a wrong approach, right? So the correct approach is this thing. If you consider this end to be positive, then this is going to be minus. It's okay, but the charge value, it is going to be 0, right? So try to grab that point properly. So here we got it as positive V, and this is just a bend. It is going to be positive V, and in this path, you don't have any sort of appliances. So therefore, there's no voltage consumption, right? Any energy consumption. So this is going to be also positive V. This place is going to be also positive V. And now the current is going through the resistor, right? Now there will be energy consumption, right? Now there will be any sort of a energy consumption. So energy is consumed. So this voltage or the energy consumption, I'll take it as V1, right? That is now V1. So at this point, now you are having a new voltage value. So this point, this green dot point, it will be experiencing a new voltage value. So that is going to be V minus V1 voltage, right? V minus V1 voltage. So this point, same, V minus V1. And if we consider this point, now what will happen? There's another voltage consumption. This is going to be V2, right? So this point is going to be V minus V1 minus V2, right? V minus V1 minus V2. And so here, same point, here, same point, and here also, eventually, it becomes the same point. So this is going to be 0, this is going to be 0, this is going to be 0. So which means we can relate this string to be 0. So if we take V minus V1 minus V2 equals 0, so if you take these V1 and V2 points here, you can see the total voltage is going to be V1 plus V2, right? V1 plus V2. So that is the most simplest way that I can explain it. Okay. So once after the session is done, if you feel like you didn't understand this thing, so please revise these things, right? Please pay attention, and you need to grab this point, right? So definitely in A-level physics, if you are following A-level physics, then definitely you will be having these calculations, right? And we will be learning different sort of what you call those laws related to these circuits, right? There are some names like Kirchhoff laws, like those stuff, right? So in order to grab those theory points correctly, then you need to have this idea how the voltage reduces once there's an appliance, right? So likewise. So this is the simplest way that I can explain here. So here, remember that if you are having a series resistor system, then it will be acting as a voltage divider. See, the voltage is actually divided into V1 and V2. V1 and V2. This voltage being divided here. See, voltage is being divided. And that V1 and V2, the total gives the final voltage value, right? The total voltage value. And if we consider about the current, so let's say current I, and here also there's no breaking points or any sort of branches. So therefore, both R1 and R2 will be experiencing the same current, right? Will be experiencing the same current, but in the meantime, will be consuming different sort of energy values, voltage values, right? And let's say, so now we need to prepare, let's say, an equation in order to get the total resistance here, right? So the best approach is that construct a resultant circuit here. So here I'm going to use RT instead of R1 and R2. And here the same voltage supply, the same voltage supply. And here current I like this. So now what I can do is here, so I'm going to apply. So our equation, I think you can remember, I forget to mention it. So V equals IR. And remember this point, uh, if they ask in the exam, what is the connection between the voltage, current, and resistance, you should write this one, right? This is the correct way. But Here, remember this voltage, this V, the actual meaning is the voltage difference, right? This is the voltage difference in the appliance. That is the voltage difference in the appliance. See, the voltage difference between R1 is V1. The voltage difference R2, the voltage difference of R2 is V2, right? We are considering the difference. So if we apply for the total system, right? We are applying for the total resistance value. So the voltage is going to be V equals IRT. This is our first equation. And if we consider about R1 in the first uh, system, so we are applying V equals IR here. Uh, so the voltage difference is going to be V1 equals current I R1. This is the second equation. And if we consider about the R2, V2 equals I R2. This is the third equation. Now with the combination of these two, these three, right? So now we are going back to this one. So instead of these V terms, we can write it with the IR terms. So IRT equals IR1 plus IR2. So therefore what will happen? I is a common term. I will be cancelled out. So therefore you will get the total resistance is equal to R1 plus R2. Total resistance equal to R1 plus R2, which means in a series system, you can just get the total resistance by adding the numbers together. So in this case, so now it is a series system. This is a series system. So therefore, directly you can say RT equals 2 ohms plus 3 ohms, which is going to be 5 ohms. And if they ask you to calculate the current which is flowing through this system, so you can take it as I. So for the whole system, right? For the whole circuit, you are applying V equals IR. So for the whole circuit, the voltage value is 12, current value that is to be calculated. Now you are applying the RT value. You are considering these two to be a one resistor, right? These two combined as a one. You are imagine like that. So 12 equals I into RT value is 5 ohms. So always remember when you are applying data points, use the units as well, right? Use the units as well. Otherwise, you will lose marks actually, right? Better to grab those ones. So the current will be equal to 12 over 5, which is going to be 2.5 amperes, right? 2.5, not actual 2.5, something around 2, right? Something around 2. So this is how we calculate for the series system, right? This is the series system. And if we consider about the parallel system, so here also we'll take the voltage V. So this is going to be positive N, this is going to be negative N. And here we'll take this one to be positive V and this is going to be negative V. So I think you can understand that point now. So this point positive V, this point positive V, this point also positive V. The reason is there are no appliances. It's just wires, right? It's just wires. There's a small deduction of voltage, but in this calculation, we assume that these connecting wires, right? That is a good point actually. If they ask what are the assumptions that you made in this sort of calculations, then you can write that these connecting wires, right? These connecting wires, they are having a zero resistance. Oh, yeah, zero resistance is okay. Always remember, if there's a resistance, then definitely there are going to be a voltage deduction, right? Voltage deduction. But in these calculations, we consider that these wires, they are not having any sort of voltage deductions. Okay. So this point is going to be also positive V, right? Positive V. This is going to be positive V. This is going to be positive V, right? And in the other way around, so I'll take a different color. Here it is 0 voltage, 0 voltage, 0 voltage. This point, 0 voltage, 0 voltage, 0 voltage, 0 voltage. So now you can see that if I use a different coloring pen, so this ends are having the same voltage and these ends are having the same voltage, which means we can simplify this circuit, right? So use these methods in your exams, right? You can simplify this circuit. So here you are having the voltage supply. So this is connected to R1 and R2 like this. So this is the simplified version, right? So in this case, you are having junctions, right? You are having junctions. So current will be going from here, here, and at this place, what will happen? There's a junction. So the current will be divided into two different ones. I'll take I1 and I2. And here you will get I1 here, and here it will be I2. And this point, again, those two current values will be joining together. And here you will get the I current, right? So in this diagram, you can draw this is to be I2, and this is I1, I1, I2, and this is I, right? And remember, in your syllabus, right, in your level, there's no need of calculating the resistance, the total resistance in a parallel system. But I know in your experience, you have seen that there were several questions that they were asking about the parallel resistor system. So therefore, I'll just explain it. But remember, it is not tested in the exam, right? So I'll use this example here. And instead of this circuit, I can draw using the RT. And here it is 12 volts. So current flowing in this manner, right? And here current I'll take it I1 and I2. Right. So first I'll use the symbols and try to uh, get the values, right? So here this end positive 12, positive 12, positive 12, positive 12. This end 0, 0, 0, 0, right? And in this diagram, what has happened? So this is positive 12, positive 12. So which makes this place also positive 12. And this is 0, and this place is 0. So which means you can get an idea that here the total difference is 12 volts. And here, so this is 12, this is 12. So which means this is also voltage difference is 12. And here, same thing, positive 12 voltage difference, right? So I'm going to use the symbols, then we can calculate the value, right? So here, I'm going to use V equals IR on R1. So I'm going to use V equals IR. Voltage is 12. I'll just write the letters, okay? So V, the same voltage, right? 12 difference, voltage, 12 voltage difference equals I1 R1. So this is my first equation. Now I'll rearrange it again, right? So I can rearrange the equation. I1 equals voltage over R1. This is my first equation. And for R2, again, I am using V equals IR. So in the same manner, I can write I2 is going to be equal to V over R2. This is the second equation. And for the whole system, I am applying V equals IR here. So I total value will be equal to V over R total. This is the third equation. So I total or the I value is the thing that you have in all these circuits. and it will be divided into I1 and I2. So which means I can write that I total value is equal to I1 and I2. So then I can apply 1 and 2 and 3 here. So it is going to be V over RT equals V over R1 plus V over R2. So here you can see voltage values are same. So it will be like this. And finally, 1 over RT is equal to 1 over R1 plus 1 over R2. And you can rearrange this equation once again. So RT is going to be equal to RT is going to be equal to uh, R1 into R2 divided by R1 plus R2, right? Yeah, yeah. R1 into R2 divided by R1 plus R2, right? So remember, this is not in your syllabus, right? So there's no need of remembering it. But the main thing that you need to remember is that once you are having the parallel configuration, the resistance value will drop actually, right? For example, let's say I'm using R1 to be 2 ohms and R2 to be, let's say, 4 ohms. So if I use it in the series manner, the total resistance is going to be 6 ohms. If I use it in the parallel manner, what will happen is that the total resistance is going to be 2 times 4 divided by 6. So it is going to be 8 over 6, which is going to be 2 point something. Sorry, 1 point something, right? 1 point something. So you can see that going from series to parallel, it decreases the resistance. So once the resistance is decreased, what will happen? The current in the path will increase, right? The current in the path will increase. So remember that point. There were several questions where they tested this thing. Please pay attention to those questions and find out the marking schemes and find out the answers as well, the perfect answer, right? So that is the main thing when it comes to resistors. You need to identify what sort of a resistance system that we are dealing with, right? And according to that, how the current values are going to be changed, right? And always remember, as I mentioned, this V equals IR, it will be representing the voltage difference, right? Always get the voltage difference. But in the exam, don't write it as the voltage difference. But when you are doing the calculations, write it as the voltage difference. Okay, write it as the voltage difference when you are applying the values. And another important thing that I need to mention is the IV graphs. So yeah, uh, for a resistor and for a filament bulb and for a diode, please go through them. And okay, so uh, here I'll write the question. IV graphs. So here, mm, voltage against current. I'll use different colors, then you can clearly understand. This is going to be a ideal resistor. Ideal means like they are the perfect ones, right? They are the perfect ones. In normal cases, we cannot find these ideal ones, right? And the next one is for the filament bulb. So it will be having a shape like this, filament bulb. And the last one is for the diode. So normally, like the reasons for these values or these shapes, it's not actually mentioned in these syllabus, but in your A-level syllabus, it is mentioned, right? So here you will be having a minus value like this, and at a 0.6 voltage value, you will be having this sort of a increasement, right? So this value, just remember it, it can change depend on the uh, it can change depend on the material that we are using to construct the diode, right? So this is for a diode. In A-level physics, you will learn these things under electronics unit in depth theory parts. Okay, then the different types of resistors. So go through them, like what are the variable resistors and the special types. That is the most important part, right? So resistors, the special ones. You have thermistors, and then you have LDR, light dependent resistors. Light dependent resistors. So for the thermistors, try to remember the circuit symbol, something like this. And for the LDR, light dependent resistors, so if any appliance is depending on the light or depending on any sort of external factor, then the arrows are pointing towards the appliance, right? So remember that arrows are pointing towards the appliance, and if it is light emitting or something like that, then the arrows are pointing outwards, right? And for these two guys, you are having the same uh, graph here. So here it is going to be the resistance, and the x-axis, it can be the temperature if it is if we are dealing with the thermistor, and here if it is the LDR, the light intensity, right? So you will be having the same shape like this, right? So remember that you are having the same shape, but with different axis, right? But different axis. But when it comes to the gradient, there are like, slight changes there with the gradient of the graph. But here we are just focusing on the shape here, right? Just focusing on the shape. And the last point that I need to emphasize is the thing about diodes. So remember, diodes are special cases, right? So this is the circuit symbol of a diode. So which this gives the direction of the current. So this is the current direction, right? So it will be passed through. But if you are using in the opposite direction, just imagine current is coming in this direction. So the current will be blocked, right? This way it is okay, right? So remember those points. Those are some important ones. And about the LEDs as well, right? Light emitting diode. So now the light is emitting, not depending. So therefore, the arrows must be pointing outwards. Arrows must be pointing outwards. So these are the important facts that you need to remember in electricity. So not just the theory parts. So here I did not discuss about the practical component and also the calculation part. But here I have given you the most important theory section related to the calculation part, right? So calculations is must. So when it comes to electricity, like 80% or 90% of the marks will be allocated for the calculation part, right? So my advice is like just go through the theory note once again, and these are some things that you don't need actually, right? So please filter the things that you need, since we are having a less time now. So it is now 20th of April. Like we have like just 2 more weeks actually, right? If we consider the May 7th, so nearly 2.5 or something like that, right? So please filter them. And the most important thing is like there's no point of going through the theory note once again and once again, right? So if you can't remember any sort of specific theory part, just go through the note once again and refer the papers that we have done, right? Uh, you can refer either the regional ones or the Edexcel your past papers ones, but my advice is to refer the not the regional ones, the other official Edexcel past papers, right? So past papers in sense like you can refer from 2020 onwards. Pay more attention to the 2023, 24, 25 those papers, right? And also pay more attention to those filtered past paper questions which I have given you, right? So utilize these 2 weeks, right? If you are having any sort of a question, just drop me a personal message, then I will be helping you. And also remember the main key point, right? Not just for physics or just for chemistry, all the other subjects, not about like English or English literature, I don't know about those things, but for the science subjects, when it comes to maths and also biology, so the main key is that you need to refer more and more calculations, right? The things that you have done. So these are just, just going like touching the surface and, refreshing the theory parts. But the main goal or the main thing is that you need to refer the questions, right? You need to refresh your memory about the applications or the different sort of calculations that we have done. So if we consider like for physics and chemistry, we have completed nearly 40 papers for each. So 40 papers means like just do the math part, then you can see how much of questions that we have discussed, you have faced, right? Nearly it will be like 1,000 or more questions, right? So I'm not asking you to memorize all the 1,000 questions from chemistry or physics. Just I want you to memorize all the applications that we have done, right? The calculations, how this calculation is done, like those things, right? I'm not asking you to by heart them. Just go through them and think what is the place that I got it wrong, and is there any sort of methods that we can like an easier method or something like that, right? So please complete those tasks within these 2 weeks, and please be engaged in those work, right? Don't just fool around here and there, since we are having a less time, okay? So yeah, that is the end for today's session. So here I just like, like rush the whole like 2 or 3 months syllabus, the theory part within just 1.5 hours. So like I am not recommending this thing like here I am just refreshing the theory parts, right? So the main thing is like you need to go through the full theory note textbook, and all the main one is the question papers, right? Give your time, allocate the time to refer the question papers, right? And so that's all for today. I'm not going to take more time, so please be engaged in work, right? I am expecting a good result from you guys. So uh, like we have completed the theory like within an year, and we have completed all the past papers, like those things, like the paper classes were conducted like nearly for a year, right? So get your maximum output. So in order to get that maximum output, that's why I'm always advising you to refer the papers, right? So please do those tasks and try to achieve a good result, right? Try to achieve a good result. So you all can do this. You got good results, good markings for the final papers as well. So please be engaged in work, and please work with these 2 weeks. Okay. So that's all for today. I'm not going to take more time. So please utilize the time, right? Okay. So thank you for joining. And another thing, if you are having any sort of problem, please do drop a WhatsApp message to my personal number, right? Okay, so I will be uploading those certain materials in the group, so please refer them as well. Okay, so thank you for joining, and have a nice day. Have a blessed week. Okay, thank you.